Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
Thanks for the introduction. Hi everyone. My name is, like they're already introduced, is Carlos Martinez, and I work at the Netherlands Design Center. Today I will be talking about software management plans and how they lead to better research. So it's since the dawns of time, as researchers and in science, we built tools to do our science. One of my favorite examples is this little device here, which is a microscope, actually the very first microscope, which was built by Anthony van Leeuwenhoek. He was a Dutch guy, and he was both a tool maker and a researcher. So he was making his own microscope by polishing small crystal beads, and he would crafted his own lenses, and with these lenses he would look into the microscopic life that he would find in water droplets from the fountain in his town and from different places, and he would write down in those days letters to the to other scientists and to the British Society of Biology, or I don't know what, and he would describe this microscopic life, microbes, small life as he called it, and describe how they looked and how they moved. And he was a pioneer of microscopy. So he was both a scientist and a tool maker. In the 21st century, we're still building new tools for exploring the universe around us, from the very small to the very big. And I think most people know by now this popular image of a black hole, which was the first image taken from a black hole with the Event Horizon Telescope. And the part that I find really fascinating is how this image was made. I watched the documentary not too long ago, which is called Watch Black Hole. It's how this picture was taken, but in a nutshell, basically, the Event Horizon Telescope, it's a telescope that is not a telescope, right? It doesn't really physically exist, but it's taken by taking observations from dishes all around the world, and they synchronize the data from all of these telescopes to create a single image coming from all of them. So I think, from what I understand, it's the equivalent of having a lens the size of the Earth and putting together all this data by using a very clever software, right? So this is not a physical telescope, it's a virtual telescope, it's a software telescope, which is the really amazing part. So research software is everywhere in science today, in the way we do research. And from the very small, from genome sequencing of virus to the very big, in astronomy, and everything in between. In archaeology, they also use research software for processing LiDAR data and discovering what is underneath the forest. And this way, they've made some archaeological discoveries of things that are hidden in the jungle in Mexico, for example. And climate scientists, of course, to very compute-intensive models of climate and of water currents in the oceans and in the atmosphere to predict the weather and to predict how the weather is going to change in the coming years. And of course, if you do anything with machine learning, you are using research software. So research software is really across the whole research spectrum, from in all disciplines, is becoming an important part of how we do research. So much that the UNESCO, under recommendations for open science, they highlight research software as part of the one of the pillars of how we do open science. So for in science, reproducibility is always an important part of what we do, because if our science is not reproducible, it's not really science, it's more science fiction. So we always want our science to be reproducible, and that means that our research software needs to enable for things to be reproduced. And that means that somebody who uses my same software in the future should be able to get to the same results. But also at the same time that somebody who uses the same software that I'm using in a different way with a different data set should be able to come to comparable results to what they have. So the key part in this puzzle is that with the software that we create, we want others to be able to use it, not only today but also in the future. And the future could be tomorrow or could be in a couple of years, depending on my type of software. But the bad news about this is that software breaks over time. So this idea that I presented in the previous diagram, that if you take some data and find some software, you can get to the same results that the previous researcher did. It's very nice, but once you get to the detective work of finding the software that somebody else used, you will probably find that if it's not being maintained, if it's not being taken care of, it will probably be broken and covered in spider webs. Because it is just the reality that when new versions of dependencies appear every day. So if you write something in Python 2, probably now you can't use it. And it's just the reality that sometimes the software that we're trying to use is just outdated and it's impossible to use. So why am I talking about this breaking software? Where does my experience of software breaking over time comes from? As Claire already said, I work at the Science Center, and the Science Center, that our mission is partly to make sure that we contribute to how research software is built and how we understand research software. So the eScience Center, we're funded by the NWO, the Dutch science funding agency, and from SURF. Which that means that our mission is to promote, to help scientists use software and use the hardware more efficiently. And we do this by having different projects, by building software in those projects, and by coordinating how people interact with software, with research software. And so the mission of the center is empowering researchers across all disciplines through innovative research software. So that's our mission. It's maybe a bit vague sometimes. What does that exactly mean? What do you actually do within that mission? So as I mentioned, we do research projects. So we help researchers in their research by helping them create software or reuse the software that they have, improve the software that they have, speed it up. So we are very involved in hands-on development of software, and to make sure that the software that we build in a project is reusable over time and in future projects with the same research team, but also that other research teams in other universities are able to use the software that we build. We also do a lot of trainings and workshops. We try to help researchers to gain the skills that they need to maintain the software over time. And we try to contribute in this way to open science to make sure that all the software that we are creating remains open and reusable for the greater good of society. And so we have projects in every domain. So from life sciences to humanities, social sciences, physics. So the center has existed for about 10 years, and in those 10 years, we've been involved in over 100 projects in all different domains, and from very short projects that we are only involved for 6 months to large collaborations in which we are involved for several years. And our software ranges from very small scripts to analyze some data that some researchers collected to creating research software infrastructures that a lot of researchers use to collect and analyze their data. So in terms of things that we do for sharing expertise, we organize trainings, we organize workshops, and we try to develop methodology for how do you build software, how do you share your software in a way that it's easier for others to collaborate in a way that is more aligned with the spirit of the FAIR principles of making software findable, accessible, interoperable, and reusable. And in order to make software reusable, you need to make sure that it doesn't break over time. and that it's usable in the future by other people, so that it really reaches its maximum potential in that way. So that's where why I'm interested in preventing software from breaking over time. So that's at the core of our mission. That's one of the main things that we do as a center. We try to make sure that the software that we create and the software that others create is as sustainable as possible, that it's as robust as possible. So with this in mind, a couple of years ago, and together with NWO, we started a working group to create some guidelines for how to manage software. So we created a working group for national guidelines for software management plans, and we had a working group with people from researchers and research supporters from different universities in the Netherlands. And we also had a sounding board with people from different organizations, nationally and internationally, to try to give us feedback into whether the guidelines that we were creating were useful for researchers and for researchers across these all domains and with all different levels of expertise, right? So we didn't want to create guidelines that were only useful for the people who are already doing a very good job in creating research software, but that these guidelines should be hopefully useful to people across the spectrum, to researchers across the whole spectrum. So we published our guidelines in October 2022, and since then we've been trying to promote the adoption of of software management plans in the Netherlands and internationally. So what was our thinking about software management plans? What we wanted to create was something that helped research to reach its maximum potential. So if we just as an analogy, if we think of software as a little plant, we were thinking of the software management plans as the things that you would do to make sure that your software can grow to its full potential. So what are those things that can help you manage your software to reach its full potential? Similar to how a data management plan helps you to make sure that your data is managed in the best way, or that it reaches its full potential, we thought that software management plans could be something similar. So they should be somewhere where you could detail all of the things that you need for your software to be alive, and that starts from thinking, what does your software do, right? What's the purpose of the software? Why am I creating it? Who am I creating it for? So thinking about who are the users of your software, and try to keep that in mind right from the time that you're starting to create something. You should also consider things like what type of resources does it need to keep running, and who's going to be responsible for your software. Is that you? Are you going to hand it over to someone else? And how long do you want to your software to be around? Is it really just for the next PhD that comes into your lab, or is it something that you want to be available for years to come? And the idea in the software management plan is to try to make all these decisions very explicit, and to make them very clear, so that you have clarity early on in your research process to manage the expectations, right? And to avoid problems later on. So, for example, if you create something that you expect it to be only usable for the next year, then people shouldn't expect to be using it 5 years down the line. It gives you a little bit of clarity, gives you a little bit of expectation management of what is within the scope of the software that you're creating and what isn't. So in that sense, the guidelines they include some requirements that that you can consider for your software, but that these requirements are applicable to different software in different, depending on what are the expectations from your software, are the requirements that you should include for your software. So not all software is created equal. So not all software can be managed in the same way. So we defined some different levels of how can you manage your software. So you can have like software that requires little management, that requires a medium level of management, or that requires a lot of management. So in this sense, there's different things from from the software management plans that you can take on board for your own software management plan or not, depending on what's the scope of your software. One thing that was important for the working group while creating these guidelines is that the software management plan shouldn't be a checklist that you have to do, a little bit of administration that has to be done to please your funder or to please your boss, but that really should be something that helps you helps your software reach its full potential, that helps you think about your software in a way that you can create a better software product for the long run. And why do we want your software to be better? Because in the end, we want to improve the quality of the science that you're doing with your software. So you want your software to be more reproducible, more reusable by a wider community. Then you need to create a better managed software. So this is a quick overview of the requirements that we included in the software management line. So we have some of these requirements are more focused on the engineering. Some of them are mostly focused around documentation, and some of them are more what we call the project management focus. So these are things that are not necessarily technical considerations, engineering considerations for your software, but that are mostly things that happen around your software, but that you should still try to manage for your software for it to be more successful. And we have this loose requirement, which is the purpose, which is something that we think you should always try to state and start by thinking, what is the purpose of your software? Why are you creating the software in the first place, and what is within the scope of your project and with what isn't? So that's why we had this as the purpose as a loose requirement, as a category that stands on its own. So like I mentioned before, we don't think that all software is created equal. So different types of software need to be managed in different way. So our friends at the Australian Research Data Commons, they created Australian National Agenda for Research Software a couple of years ago. And we found this, they in the National Agenda for Research Software, they had this classification of different types of software, which we found really useful because it helps you think about software in different types of software that has different purpose. So you could have things that are analysis code, prototype tools, or research software infrastructure. And in a sense, analysis code is code that is used or software that is used for only a small analysis, just for a very limited scope. Maybe you only want to use this analysis code for one specific paper, for one specific publication, and then you don't need to do a lot with it in terms of long-term sustainability. As long as others can read your code in the future, that's probably good enough. Prototype tools are somewhere in between. That is something that you want to use for an experiment, maybe for multiple experiments, to demonstrate an idea or to show a new method. And maybe it's somewhere in the middle, that you want others to use it, you want others to try it, but maybe you don't. It's not an finished product quality software, so maybe you need to be somewhere in between. And then you have, in the other end of the spectrum, research software infrastructure, which is the software that probably you expect a lot of people to be using, that you probably expect to have a wide community of users depending on your software. So this is the type of software that we think about as software that if it stops working, somebody is going to shout. So of course, we really like this category because it helped us think about three different types of software that sit in these that needs to be managed in different ways. The one thing that we didn't like about this categorization is that in practice, whenever we try to classify a particular piece of software in one of these categories, we always find exceptions that things it's not quite analysis code, but it's also not a prototype that fall in between. So we use this as a framework to think about the software and how it can be classified. But in the end, every piece of software has its own particular needs, and it usually falls somewhere in between. And we think about the software that should be managed that is somewhere in this spectrum, and that is not necessarily in a specific box, but then the authors of the software are the ones who need to decide where is your software, how in the spectrum, and how much effort do you want to put into managing your software. So in that sense, we think that software management plans should be tailor-made for your specific piece of software, and that these requirements that we outlined in the guidelines are like a menu. There are different items in the menu, and you can pick and choose things that you think are suitable for your software. So we've run a number of workshops with in the Netherlands with research software engineers and research software supporters in the community, where we go through this exercise of explaining what are the requirements that we have in the software management plan, and then people decide which of these ingredients are important for their software management plan and which ones aren't. I've taken some pictures of these workshops, and these are two that I really like. One that is very simple with just like a few ingredients that are important, and another one that has like a lot of things that they say, well, my software really, I want to include all of these things in my management plan because these are all the things that I find important for my software. And it's not that one is right and the other is wrong. These ones are perfectly suitable for the different types of software that are that were used by these people, so or developed by these people. So I'll go a little bit into the requirements just so you know what is in our guidelines. And as I mentioned, purpose is where we usually think that it's a good starting point to think about what's the purpose of your software, and it's a category that we think it stands on its own. So you should start by thinking, what problem does your software solve? Who's the intended audience of your software? And what are the advantages and limitations of your software? So am I building something that that is really needed? Am I building something that actually there's already a tool somewhere that I could just reuse, and then there's no point actually building something new? Or no, maybe the tool that I'm building it because it's similar to another tool, but the existing tool only works with small data sets, and I want to work with large data sets with large volumes of data. Then those would be the advantages, that the advantage of my software. Why the reason of creating the software is because it handles larger amount of data or specific formats of data, or it handles the data in a faster way or in a different way than existing tools. And that will give me the distinct thing that the reason for my software to exist. And then that will also help me think about what is in scope for my software and what isn't. So that's important part of thinking, what are the advantages of this thing that I'm creating, and what are its limitations. In terms of the engineering focus requirements that can be in a software management plan, there we cover things like version control, testing, packaging, and software quality of your code. So version control is something that is probably useful for most types of software. Testing, it's also probably most types of software you should test at least a little bit. And then it's good to know how are you going to test your software. maybe if it's just an analysis code, you just want to check, have just like a small test that tells you this, yes, this is still producing the results that I expect. And if it's a more a research software infrastructure, maybe you want to have more uh, stricter tests and automated tests to make sure that every time you introduce a change in the software that it's not breaking and it's still doing what you think it should be doing. Packaging, it's somewhere where you start thinking, okay, maybe not all types of software need to be packaged, but if you expect other users to be using your software, then maybe it makes sense for it to be packaged in a way that it makes it easier for them to use. And software engineering quality, again, depends on where your software sits. You can say, well, I just want to make sure that it's my software is fulfill some quality requirements that I have in my domain, like code styling or linting of my software. But if it's a really high-end type of software, so some research software infrastructure, research infrastructure software, sorry, that you expect a lot of people to be using, then maybe you want it to be very modular, very nicely engineered in a way that other people who are contributing to the software may find it easier to contribute to it in the future. And that includes a future version of yourself. In terms of documentation, that also, depending on the type of software that you're creating, you may need more or less detailed documentation, and maybe you should think about different users of your documentation, right? So who's going to be reading your documentation? If it's just an analysis script and something that's very on the lower end of the management spectrum, probably just documenting your software for the user. The user is the same person as the developer in that case, and maybe you just need to write what the code does and which line is the critical one in your small script. But if you have a software where you expect to have more users and there's a distinction between your developers and your users, maybe you want to have different documentation for the people who are going to be using your software and for the people who are going to be contributing to the software. So for example, if you have some software that runs a web service, maybe you have some form of documentation for people who will come to your website and will click in some buttons in the user interface, and you want to explain how to do that. And you will have different type of documentation for developers who are going to be tweaking that what the software does behind the scenes and what the where should they change things in the software if they want to modify the behavior or add new functionality. We included this additional category, which is deployment documentation. This could be if you have a software that runs as a service and you have a third person that is going to install your software in the server and make sure that it stays running, but they're not going to modify the software. Maybe you want to have some instructions on how to install it and how to test it, how to make sure that it's still running, and other maintenance tasks that need to be done, like backing up the database every 6 months or whatever, that are not necessarily part of the development of the software, but that are helpful for the people who will be making sure your software stays running in that server. So again, depending on the type of software that you're creating, you may need different types of documentation. And the project management focus of requirements. So these are different things that are, as I mentioned, not necessarily related to the code, or they're not necessarily technical things about your software, but are more other considerations that are necessary when you're developing your software. So, for example, what type of license are you providing with your software? Licensing is always a tricky issue, because you have to make sure that your license, when you license your software, that it's compatible with any dependencies that you're using. So if you are using software, if your software uses libraries that are GPL, you need to make sure that your software is also compliant with the restrictions that the license of your dependencies implies. GPL, so if you build on GPL software, you probably need to license it as GPL as well. And so that this is something that it's that you need to consider when you're licensing your software. Maintenance is another important aspect of your software, depending on what's the expected lifetime of your software. If you expect your software to be available for a longer period of time, you need to make sure that someone will maintain it, maybe yourself, maybe someone else, but then you need to make sure that there's resources for maintaining your software in the long term, that there will be someone employed at your organization that will be able to maintain the software. And for how long do you think that maintenance is necessary, depending on what promises you're giving with your software. Because we're talking about research software, and in the research context, citations are usually an important, are the main currency in research. Maybe you want to consider whether your software should be citable, and then you want to include citation information around your software. What type of repository, which repository or repositories you will use to share your software, to archive your software. So that's something else that if you have software that you want to be sharing with more than one person, do you need to put it in a repository, and where? Again, things that are more for the higher end of the spectrum. So for software that requires more maintenance is support and resources. So these are different types of resources. It can be if you have software that runs as a service, then do you have a server where it can run for the long term, for the time that you promise it to be running? Then you need to have some infrastructure available for it. If your software requires some training for people to use it, then will you have someone who can provide the training in the long term? And basically the thing to include in your software management plan is to think about who's going to be maintaining your software, and how are you going to make sure that you have those resources available in the long term, or in the term that you want your software to be available. And finally, the last consideration, the last requirement that we think should be included in software management plans is a risk analysis. So this refers to risks that are not directly related to your software, but that are around your software, things that happen around your software that may affect how your software runs or how your software is distributed. So, for example, if you share your software, you ship your software using Docker, what happens when Docker changes their financing model, and if they start charging for hosting Docker images, then do you need to change something about your software? Or if your software runs on Amazon Cloud or Microsoft services, what's the risk that you're taking there, that they will change their how much they charge for their services, their rates, and that's a risk that you have then when you're creating a software that depends on Amazon services, or what's the risk that you have with if your software uses with the introduction of other tools like ChatGPT. Does that change how your software is used, because suddenly nobody wants to grammar checking tool because everybody's writing everything with ChatGPT? So is that something that affects your software? And if it does, then how are you going to manage that risk? So that there's all different types of considerations that can fall in this category, and it really depends on the nature of your software. How do you manage those risks, and how do you assess those risks? So this is there's a lot of requirements. There's a lot of things that you need to think about, and of course, nobody expects anyone to be an expert in all of these topics. So I have some resources that are useful places that you can get started to find guidance on this topic. Actually, the Science Europe published a recommendation on research software at the end of last year, and they recommend that there should be some guidance for managing research software. So in that in that sense, I think that the Turing Way, it's a very good resource that provides a lot of information about this, about how to address all of these requirements. So if you don't know, if you need to include version control for your software and you don't know where to start, the Turing Way has a chapter on version control that can help you get started in that way. Same thing with other topics like licensing, citing software, code testing, code review. There's a lot of topics that are included in these requirements that can, if you don't know how to address them or you need more information about those, the Turing Way is a great resource to get started. At the Science Center, we also have our research software support masterclass, which is it's a course that we provide a couple of times per year, which covers some of these topics, and it just provides a very gentle introduction to many of these topics. But it's also an online resource that can be used as a self-study material, and that it's available to the general public, to the wider research software community. Another resource that we created at the eScience Center is our Python template. So our Python template is it's a tool to kickstart Python packages that can help you comply with some of these requirements. It can help you include version control. It can help include citation information. It can help include unit testing when you're starting a new project in Python. Unfortunately, it is limited to Python, so sorry, our users, but for Python users, that's good news that there is something where you can start. And the Python template has, because not all software is created the same, we have different profiles that you can choose. So you can choose like a minimum requirements profile that only includes the basics, and everything else you have to add yourself. So that's great for analysis codes. And we have it has a minimum recommended and let me choose profile. So if you are going to develop a Python package that you really expect to be of the research software infrastructure type, then you can use let me choose and choose everything, every possible thing that is included in the template, and that should help you to get started with your Python package. So that was the last thing that I wanted to say about software management plans. So thank you everybody for your time and for your attention. Yeah, thank you.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.